Hi algebra students, this is our introduction video for our lesson and our last lesson of this unit on solving problems with linear inequalities. This lesson is going to be all about combining everything we've learned in this unit. So mainly, if I give you a story, can you represent it with an inequality? Can you create a graph of that inequality? And can you use that graph to help you understand the situation? And so in this introduction video, we're going to use this story here. I'm going to ask you to go ahead, pause this video to read the story, and then try number 1, where you write an inequality to represent the situation. Come back once you have an answer. So in our story, we find out that they're planning a field trip for a minimum of 120 students. Earlier in this unit, we learned words like minimum are really helpful for us understanding that if it's a minimum of 120 students, that means 120 students or more. And so that would mean when I go to write my inequality, I'm going to be using that greater than or equal to sign. We also know that students are either going to be in a van or a bus. Each van can take 8 students. So in my inequality, I'm going to say there's 8 students times the number of vans. I'll use X to represent the number of vans. And then each bus can take 20 students. And so we are also going to have 20 students in each bus. And I'll let Y represent the number of buses. Put it all together, we've got 8 students in every van plus 20 students in every bus, and we are going to need a minimum, so greater than or equal to 120 seats for those students. This right here is what your inequality looks like. If we want to create a graph using this inequality, the first thing I'm going to do is put in some labels. So we said here my y-axis is going to be the number of buses, and then my x-axis is going to be the number of vans. To create our graph, there are 2 ways you can do this. You can either find your x-intercept and your y-intercept by substituting in 0, or rearranging this inequality so that you have y by itself, so you can use slope-intercept form. I'm going to go ahead and do it using the intercepts. So if I let y equals 0, that would give me 8x equals 120, and so then when I solve that, I get x equals 15. So I have an x-intercept at the number 15, which is right here at the end. And then when I let x equals 0, that gives me 20y equals 120. And then when I divide both sides by 20, we have a y-intercept at 6. And so that gives me a y-intercept right there at 6. Like I said, you could also solve this inequality for y and use y equals mx plus b to help you graph this. Either way, you get the same line. And so our graph would look something like this. Now I've got the line as a solid line because this has or equal to, so that means any point on the line would be a solution. The final part of this is figuring out where to shade on my graph, and we can do that by substituting in a point. If you've been here for my lessons, you know I love using the point 0, 0, and so if I substitute 0 into my inequality, we get 0 is greater than or equal to 120. That is not true, so it means 0, 0 is not a solution, which means the solutions are not on this side of the graph. They must be on the other side. And so to finish my graph, I would be shading everything up here. And so here is our graph representing this situation. None of this is really new. We've done parts of this in different lessons, but we are combining it all together, this idea of representing a story with an inequality and then using what you know about graphs to help you graph this story. There's 2 other questions with this, and they have to do with, do we understand what this graph is telling us? So number 3 asks, which combination is not a possibility the school could use for their field trip? And then we've got a bunch of different combinations here. One way you could figure this out is by substituting and doing math, right? So figuring out 10 vans. Okay, each van can take 8 students, so 10 vans can take 80 students, and doing all this math. But now that you have this graph, there's a much faster way. Go ahead, pause this video and try answering number 3. See if you can figure out which combination is not a possibility using this beautiful graph we've made. The way we do number 3 using our graph is by finding where all of these are on the graph and seeing if it's in our solution area or not. So for example, 10 vans and 5 buses, 10 vans, 5 buses, that is this point right here. It's in the shaded area. The shaded area represents possible solutions. So that means this would be a solution. They could take 10 vans and 5 buses for at least 120 students. If we keep going, 7 vans and 10 buses, 7 vans, 10 buses is right here. That's in the shaded area, so that would also be a solution. 0 vans and 6 buses, 0 vans, 6 buses. That's this point right here, my y-intercept. It's on the line, so for me to decide if this is going to be a solution, it depends what type of line we have. Because it's a solid line, that means any point on this line is going to be a solution. If you take 0 vans and 6 buses, each bus is 20 students, so that would be equal to 120 students. That is a possibility. So it's looking like it's this last one, 4 vans and 4 buses, 4 vans, 4 buses is right here. It's close to the line, but it's not in that shaded area. So this one right here, that would be our combination. That is not a possibility. And if you do the math for that, you see that it's less than 120 students. There's one final question. Is the point 10, 12.5 a solution point? Explain why or why not. I'm going to ask you one last time, pause this video and try this one so that way you can check and see how you're doing. So if I go to use the graph, 10, 12.5, 10, 12.5, it's up here. So it's definitely in the shaded area. But think about what this means. We've said earlier, X represents the number of vans, Y is the number of buses. So if this is a solution point, what does that mean? It means they can take 10 vans and what? 12.5 buses? That does not make sense. So in this situation, I might say mathematically, yes, it is a solution. If you were to substitute these numbers into your inequality, you would have something that's greater than 120. The math does work. But in the story, or maybe I say for the situation, my answer would be no. And the reason is you can't have 12.5 buses. That does not make sense in this story. In today's lesson, we're going to be looking at more situations like this and practicing writing inequalities, creating graphs of those inequalities, and then answering questions to see how well we understand the situation after we've made the graph. Thanks so much for watching and have a great rest of your day.